Hello everyone, and welcome to my Tech Talk on the Informix Sysmaster Database and using it for monitoring and performance tuning. It's good to see a lot of old friends out there, and this is going to be fun. This webcast is pre-recorded, and the slides will be available at the IIUG website. Even though it's pre-recorded, please mute your line. Any background noise will distract everyone. And you can use the chat button to ask questions. I'm going to be online monitoring the chat, so put questions in the chat and I will be glad to answer them as we go along. I'm Lester Knutsen. I've been working with Informix since 1983. That's about 40 years. It's been a wonderful experience. I'm retired and looking forward to new adventures now. But I was one of the founders of the Washington area Informix user group and also one of the 5 founders of the International Informix user group. Now, the focus of this presentation is the Sysmaster database and my favorite scripts. And we'll take a look at a bunch of stuff here. I originally was going to start out with the 12 newest, but then it expanded way beyond that. If you want to download the Sysmaster scripts, in fact, I would recommend you do this. Go to my website, advanceddatatools.com, download Sysmaster 2023.zip, or go to the page that says Sysmaster. Let me show you how that works. Okay, on the Advanced Data Tools website, the quickest way is to go to Free Tech Info here at the top and go to Sysmaster Database. And this will take you to all the presentations I've done on the Sysmaster database. And right here you can download the latest scripts from the Sysmaster database, the ones that I am going to use in this talk. And there are 58 scripts there, and I'm not going to go over all of them, but I'll talk about my favorites in here. And I've updated all of them. I've been testing them with Informix 14 FC9. Which is the latest version. And just as an example, here are the scripts that we're going to use today. And if I do an onstat-V, you can see I'm on 1410 FC9. Okay. First thing is there's a disclaimer here. These are experimental scripts. Use them at your own risk. They're continually being developed, and I have tested them. A lot of these scripts go all the way back to 7.1, and I've tested them all on FC9. The latest version, I've also worked with them on 12.10 FC15. And where I showed you just now is where all the past presentations are. But please go download the latest version because I've changed, all the scripts have been touched and they've all been updated. Now, what is a Sysmaster database? It's a peek into the shared memory structures of Informix. It's and you can actually see the code. It's really nice. If I come over here, and VI Informix etc Sysmaster, that's the code that is used to create the Sysmaster database when you start up the server. And what it does is it creates a bunch of tables and points them at shared memory. It points them at the control structures that are used both for OnStat and for the server internal working as it's running. So if you do an onstat-p and you do a similar query from the Sysmaster database, you're going to see the exact same data. Now, it contains a lot of server information. It contains DB space and chunk information. It contains database and table information. It contains user session information, and it also has the current running SQL. Now, it's dynamic. When someone logs off, their data is gone from the Sysmaster database. It only contains what's going on in memory right now, and this is a key point. You're not going to find a query that ran 5 hours ago. You'll find what's running right now. Now, the Sysmaster database is in shared memory, but to make it more friendly, Informix created a number of views, and some of those views can be very complex. One in particular is syslocks. It's a view that joins 6 different tables. And if you have a lot of locks, like 1,000,000 locks, you're going to create a 1,000,000 record temp table. That can be slow. The other one I've seen problems with is a syspt, listing all the tables. If you have a database with 600,000 tables, like one of the customers I've worked with does, that can be slow to access some of that information. So most of the time it's going to be very quick, except for a lot of locks or a large number of tables. It's different from a regular database. You can't update the Sysmaster database. If you could, you would corrupt the server. You can't drop it. You can't do DB schema on it. You don't need to do DB schema because I showed you earlier where the SQL is that creates it. And that, by the way, is the best place to learn about the Sysmaster database, is to look at that SQL script. Now, when you read from the Sysmaster database, you're using dirty read isolation. So it's dynamic. You may get inconsistent results because the data can change as you're looking at it. It also uses unbuffered logging for temp tables. So the temp tables are going to be logged. That's the other reason views created in the Sysmaster database may be slow. Now, it will change. It has changed. One of the first things when I get a new version of Informix is I run through all of my scripts to make sure they still work. So far, with the exception of some minor changes, they all work. And the ones here should work with 12.10 and 14.10. So let's talk about the Sysmaster database. And this talk is going to be in 4 basic areas. First, I'm going to talk about the server performance scripts. And these are the scripts I'm going to talk about. The first one is, how do you measure the time since the server has been reset? Okay, the first thing we're going to take a look at is one of the tables that stores basic information of the server. And this has basic stats. One of the key ones is it tells you when onstat-z was last run, which I use all the time for most of the ratios that I'll talk about in this script. The table is sys shared mem vals. And there's a field called SHPFCLRTIM that has the time the stats were last cleared with onstat-z. It also has the page size of your server. If you're on AIX, this will be 4K. On Linux, this will be 2K. Different operating systems have different default page sizes. And this is very important to use on a number of calculations. So, when were the stats last cleared? Well, let's take a look at this first script. And I'm going to fire up DB Access, pick the Sysmaster database, and go to Server Uptime. And so this tells me that the current time is Tuesday at January 31st. The server was booted up on the 23rd. The stats were last cleared at the 23rd. Here's how long the interval has been since that, 8 days, how many seconds, and how many minutes. I can use these numbers to calculate how many KB per minute am I running, and how many logs per hour am I running. All these are very helpful numbers for calculating things like ratios. And the first script I want to take a look at is something I use for calculating the IOPS and throughput for AWS. If you're moving to Amazon Cloud, one of the things you need to pick is how fast you want the disk for. And the more IOPS and the more throughput you buy, the faster your disk will be. If you move to the cloud and just go with the defaults, you're going to end up with a very slow system. So this tells you what and I'm using Amazon's calculations. They say IOPS is disk reads plus disk writes divided by the seconds. That gives you the IOPS per second. And throughput is disk read bytes plus disk write bytes divided by the number of seconds, and that's your throughput. And so that's what I do here is I calculate the throughput here. And let's just go take a look at an example. So AWS IOPS is a script, and there it is. And so this tells me that the average, and this is important, this is the average IOPS for this server is 730. The average throughput in bytes per second is what would be that 1.4 million bytes per second. Now this is the average, not the max. And so when you move to AWS, you need to use this as a minimum starting point for the speed of the disk you want. You want to add about 20, sometimes 50% more to be able to handle throughput. The other way I really like to do it is pick a busy time on your system and do an onstat-z to clear out the stats, run it for an hour, and then run the script. And that will probably give you a more realistic average. This has been the average over the weekend when I was doing nothing on a server. So this is a very low average. You want a realistic average for what your disk I/O and throughput needs to be. So that's my first tip, is if you're moving to the cloud, and the same works for Microsoft and the other clouds, this will give you a good starting point for the speed of the disk you need to consider. The second one I want to talk about is the buffer turnover ratio. This is one of my all-time favorite. Art Cagle, a colleague of mine who's done a number of these tech talks, has a rule on buffer turnover ratio. And that is your buffers should not turn over more than 7 times per hour. And so I've created a script. And if I go over here to server buffer turnover ratio, it will tell me for my 2 buffers, I have a 2K buffer and a 4K buffer. Now remember, this is the average over, 8 days. That included a weekend when I was doing nothing. But the turnover ratio has been 10 times an hour. That's a little bit, but not so good for the 2K buffer. For the 16K buffer, the ratio is very low. It's 2 gig. This is one of the first things I do when I would do performance tuning gigs with clients. I would go look at their turnover ratio. And I've seen numbers here as high as 30 times an hour. Now you imagine that. Your buffers are getting trashed 30 times an hour. That's like 5 times every minute. Everything in buffers is getting overwritten. Your performance is going to be really bad if that's your buffer turnover ratio. And I used to work with clients, and we would usually, one client I sat down, they were doing it 300 times per hour. We built a plan over a month. We slowly, incrementally increased their buffers until we got their buffer turnover ratio down to under 10. And so that should be your goal, is to use this to see what your buffers are. If they're bad, add buffers, and then that will improve your buffer turnover ratio. The other script I like to look at is memory segments. And where is your memory that Informix is using? And let's go over here to server mem segments. So here's a script that goes out and it tells me what my Informix virtual memory is. And I've got one message segment, one resident segment. I've got 2 buffers. We saw that earlier. And I've got 9 virtual segments. And down here it lists the actual 9 specific ones. What I like about this script is it tells me how big the virtual segment should be. If I add up all these segments, this is how big it should be. And I'm missing out quite a bit. Because this memory is fragmented all over the place, it's going to be quite a bit slower accessing it. And so let's take a look at my onConfig. And my current virtual segment is 200,000 KB. That's way too small. I need to make it about 2.8 gigs. So this sort of tells me this is how big I should make this virtual segment to have all these segments fit into one virtual memory segment. Here's just another example from another server I was running this on. Then my next one is what I call my ratios dashboard. And I wanted one script that would sort of give me a summary of all the data. And this is based on a union of 20 other scripts. And they're all calculating different ratios for me. So let's take a look at it. It's called the Performance All. I'm going to run it, and there are 31 rows that come back, and it tells me everything from how long the server's been up, what my CPU time is, my total disk I/O in pages, my total buffer I/O in pages, how much memory I've used, how much is resident, how much is virtual, how much is buffers, how many scans I've done. I've done 484 per hour. Now remember, the stats have been there for 8 days, and I had a weekend. So if I had set the stats yesterday, it would probably be quite a bit higher because I've kept the server quite fairly busy the last 2 days. How many sorts I've done, how many sorts have been in memory, how many disk sorts, how many sorts per hour. I'm doing 322 sorts per hour. My buffer reads per hour. This is a key number because this tells me how much KB. Well, this tells me buffers, and I can multiply that out and figure out what the KB is for that. How many commits per hour I've been doing. How many buff weights I have. I've got a lot of buff weights, 8,000 buff waits per hour. How many checkpoint waits? I've had 60 checkpoint waits per hour on average. How many locks? I've had 200 deadlocks. So this is sort of a dashboard that gives me a summary of the performance of my server, and it will give me a series of things to go figure out. Now the way this works really good is to run this once a week and save the output and then compare it, and you can then see if your performance is getting better or getting worse. And after you run it, do onstat-z, so you zero out the stats and start all over again. Now, this data comes from a table called SysProfile, which is very important. It's a very simple table. It has two fields, the name and a value. And the values and the names all look like onstat-p. So if I here are the values in that table. I just did a simple select star from it. And it's basically the onstat, same data onstat-p gets, but you can now write queries and format the data in a way that is helpful for you. And here are a couple of examples of other scripts, servers I've run this on. Now, it's really important when you're doing performance tuning to follow a scientific method. And you define a problem, you measure, you build a test plan, you do an experiment to see if it fixes the problem. And if it does, you're good. If it didn't, you go back and do it. And you repeat this over and over again. Some of you who have been in my classes have seen this. This is the benchmark worksheet I do. We take a problem, and this is a script I have students work on, and we first establish a baseline with no changes. How long does a script take to run? This takes 17 minutes. And then we make changes, and as we make changes, we record the time plus how much CPU is being used by the server. And this is server CPU time, and how much I/O is being used by the server. And then we make changes until here we took a script that took 17 minutes and we get it down to 21 seconds at the end. It took 651 CPU cycles, and it ends up taking 9. That's sort of the goal of this. Now, I wanted a script to get these numbers. You can get them from onstat-p, and I used to make students add them up and add, page reads and page writes. That will give you the disk I/O and page reads and page writes. But I've created a script called just server performance that gets all that for you. And this is something when I'm running benchmarks I use, because this tells me how much CPU time the server's taken, how much the I/O has been, and how much memory has been used, ready to plug in. Now, the second area I want to look at is checkpoints and logs. This is on the server, and there are 3 scripts here I want to show you. The checkpoint summary basically takes a look at the last checkpoints, and it will give you some information about it. Let's go take a look at it. I keep getting out here. Checkpoint summary. So I've had 20 non-blocking checkpoints in the last so many hours. Now, other times you'll see blocking and non-blocking checkpoints. Here's an example where I ran it earlier, and I had 8 blocking checkpoints and 20 non-blocking checkpoints. Right now, I only have 1 row, and they're all non-blocking. So everything is really good right now. But when I'd run this before earlier, a couple of years ago, I had 8 blocking and 20 non-blocking. The blocking are the checkpoints that stop people from doing stuff. The non-blocking checkpoints don't block anybody. And this tells me how much time was spent in the critical section. This is a sum of all the time in critical section. This is the max. So 1.7 seconds was the max. That's not bad for the blocking checkpoint. That basically stopped people from doing stuff for about 1.7 seconds. Now, for logical logs, you want to know, and let me pull that up. Let's see. You want to know how your logs are being used, and do you have enough logs? If you're doing HDR, high availability data replication, how much server is going to the secondary servers? That will be the size of your log. And what I think is really important is, what's your log turnover rate? I like to have enough logs for 4 days. So if my log backup mechanism breaks, I can go for 4 days before it stops the server. I also like to have the logs turn over about 12 to 24 logs per hour. And this little script is going to help me plan that out. And so I'm going to take a look at log usage. And it tells me I've used 79 logs. Now look at this though, the start time and the end time. I've wrapped those logs around like crazy. I've been running a bunch of stuff the last 2 days. And I'm going through 2,187 logs per hour. So I'm going through these 79 logs really fast. This tells me that my logs are too small. I want to see them between 12 and 24 per hour, not 2,000 times per hour. This tells me how many pages I am going through per hour. So if I was doing HDR, I would be sending that many pages to the secondary servers. So this is really helpful in trying to figure out how your logs are doing. The second script I have, and this is more of a maintenance thing, is when are my logs not backed up? So let's take a look at that. Logs not backed up. There should only be one row here. If you have more rows here, that means your logs are not backed up. This is the kind of thing I set up as an alert and say, if I get more than one row back, send me an alert, because that means my log backup mechanism is not working right. And what users are using what logs? So I've got a script here called log position. And you can see I've got a bunch of stuff commented out, which you can comment in if you want to. And I run this, and this tells me, okay, here are the users. This is the log they started their transaction in. Here's the current log. So far it all looks really good. They're all at about in the current log. What you want to look for, I have 79 logs, remember. If this difference was greater than 79, I would be in trouble. In fact, at 50% of that, I would get a long transaction error. And so this gives me something to look at in terms of deciding what user what it is. Now I'm running everything as Informix, which is why you see the username here as Informix. You would run this and see your usernames here, unless you also run everything as Informix, which is not a good practice, by the way. Okay, now let's talk about DB spaces and chunks. And I've got really just three scripts I want to talk about here. DB space free, chunk IO, and DB space IO. DB space free is one of my old favorite. It was a script I wrote many years ago, and I wanted something that would look like the Unix df command that would show me how much was the percent free. And I wrote this years ago. It was probably one of the first I wrote, and it's been run on a lot of systems. I used to have it run every night and email it to me, and I used to get emails from all the servers I monitored like that. It's a really good practice to know. And so you can then look at this like the plog is 0 space free, but that's okay. It's not going to grow, so I don't have to worry about that. The log DB space I don't have to worry about. This data DB space has 14% free. I should probably worry about that. That means it's filling up, and I need to go figure out maybe add another chunk to it, maybe extend that space. So the other two scripts, and DB space and chunks, they both get the data from the same place. One is summarized by DB space, the other is at the chunk level detail. This goes out and gets you your reads and writes per chunk and per DB space, the page reads and writes per minute, and the key is what's the total IO percent. And so let's take a look at let's just look at DB space IO. So this tells me that the biggest, and you notice that I have these sorted. Let me go here. That's a great thing about Sysmaster scripts is you can sort them. And I have an order by here, so they're sorted by 4, which is the name. You can sort it by the percent, the size, whatever's filled. Just change the 4 to whatever you want it to sort on. And this tells you what's going on your DB spaces. Now, something I like to do, you may have noticed in a couple of the other scripts, is I have an unload statement here commented out. Let me show you what that looks like, what I do with that. I'm going to uncomment that out, run it. It outputted 7 rows. And let's go take a look. I'm going to cat. Let's look for it. I'm going to cat it. What I like to do is I will copy this in and put it in an Excel spreadsheet. And let me see if I have it handy. This is one I did a couple of years ago. But that way I have this, a lot of these stats, I will keep them over time in a spreadsheet like this so I can see what's happening over time. And this basically gives me a idea. I'll show you how to do this on another one coming up. So here's this free, here's a DB space IO. The chunk IO is the same as the DB space IO, but it's down at the next level. The next section I want to talk about are session monitoring scripts for your performance and for your sessions. The first one is session stats. It's a basic one. Go back into DB access, query, connect to the Sysmaster database, session, where is it? Session stats. And you notice again, I've got a bunch of stuff commented out. You can uncomment and comment things as you need it. Sometimes you'll want to look at like who's doing sorts, and then you'd uncomment out sorts, or who's doing the most locks, and then you'd uncomment out locks held. But this gives me a quick summary of what all the sessions are right now. And again, the key point, this is right now. As soon as someone is gone, their session information is gone from memory. It's gone from the Sysmaster database. This doesn't keep it over time. So that's why if you want to keep it over time, you want to put an unload statement in it and unload it so that you can save it. Now, the more interesting ones, I think, are the session lock wait and the session wait list. And so let's take a look at these. The session lock wait tells me who's running and who's waiting on a lock. So here I have a database, a user, their session ID. They are waiting. So session ID 1154 is waiting on 1151, and their lock type is X. That means they're waiting on because they're doing an update. Here's another one where the session ID is waiting on this session ID. Here's a session ID waiting on another session ID. So you can go see right now on your server who's waiting on what locks. And this is helpful. If someone comes to you and says, I can't get into this table because somebody else has it locked, you can run this and see if it tells you who's got it locked. Now, again, if they finish the lock and release it, it's going to be gone from this table. So you won't be able to go back and see who had a lock 5 minutes ago. The other one I like is the wait list. And here I'm looking at sessions and saying who is waiting on a latch, waiting on a lock, waiting on a buffer, waiting on a checkpoint, waiting on a log buffer, waiting on a transaction, or is in a critical section of code. And so if I run that, you can see here I've got a user waiting on a lock, here I've got a user waiting on a lock, here I've got a user waiting on a lock. I think right now everybody's waiting on locks. Oh, here's one. This user is in a critical section of code. That means they are doing an update right now. So those are two very handy scripts for seeing what your user sessions are doing. Again, they're a snapshot. As soon as somebody's session finishes, it's not in memory anymore. Now, let's talk about tables. And I've got a lot of information here. Okay, table performance is really important. You need to know which tables have the most I/O, which tables have the most sequential scans, because that may mean you're missing an index, which tables have wasted space, and which tables are about to run out of free rows. And I'm going to show you scripts to do all of these. First one is table info all. This is everything you want to know about all your tables, and this is really a good example of you run this and load it into Excel spreadsheet, especially if you have thousands of tables. Now I've updated it to exclude the system tables and only do tables. There are earlier versions I had that included the system tables. So table info all is a script, and I'm going to go ahead and uncomment out the unload, and it's just unloaded 27 rows, and I'm going to show you how I copy that to Excel. So there, I've catted it to the screen. Here's where it starts. Make sure you pick the right place where it starts and end, because if you copy it in, it's not going to work otherwise. So I'm copying it there. Now I'm going to fire up Excel. And where's my Excel? And I'm going to say new. And I'm going to get a new spreadsheet. And I'm going to paste, whoops, got a paste special. I always forget that. Paste special and tell it you're pasting text. And it brings the data right in. Now, because I've done this a few times, I've trained it that Excel knows that the vertical bar is the column delimiter, and so it puts them in columns. If it doesn't do this, this is what you do. You go in here and you go to data and you say text to columns, and it's already done it, so it can't tell it. But under text to columns, you tell it to convert the vertical bar to a column. So it will put everything in one row here the first time you do it, and then you do text to columns, and that will convert everything to rows. Now I've got table headers already here, so I'm just going to go over here, bump, and you know, you can change what you collect, so your headers may change, but now I've got my data right here, and I have to do a few formatting little things here in Excel. Let's change this to a percent. So that it looks like a percent. Let's give it some decimal places. So I can see here, this table has the most I/O, and that's my order line table. My order table has the second most I/O. My stock table has the third most I/O. My item table has the next most I/O. But I do that all the time with these scripts, is I output them, copy them to Excel, and then I can save them. And then this is the kind of script that you can show management and say, okay, here's the results of our data. So questions to ask about your tables. Do they rows fit on a page? Do you have free space? When are you going to have to hit the end of out of free space for new extents? How big are your tables? Which ones have the most lock activity? This is a key one. Not only is I/O important, but which tables have the most locks? Which tables have the most sequential scans? And what's your percent of buffers that are read by a table? And could a table be partitioned and benefit from partitioning? Now, this does a join between three tables: systable name, systab info, which is an undocumented table, and syspt prof, which has all the performance information. Now let's take a look at a couple of these subscripts I have here. Get out of this, go back into DB Access, pick the Sysmaster Database, choose Tables with sequential scans. This is one of my favorite. This tells me that in the Benchmark 2 database, the bills table has had 7 sequential scans, and the byte scanned is what's important. I've got another table down here that has 3,000 scans, but the byte scanned here is quite a bit more than the byte scanned here. Now, this may indicate that I'm missing an index. It may be that my code doesn't have a where clause on it. You need to go figure out why it's getting a sequential scan. For big tables, this can be a problem. And when you get down here to this product table, it's had 8 scans and there are only 8 pages scanned. That's not a problem. The BMSQL district has had 1 scan and it's 56 pages. That's not a problem. You want to worry about when there are a lot of scans and there are a lot of pages scanned. Wasted space. Let's take a look at this. What I'm looking for is tables which have wasted space, and here's a really good example. The row size of this table is 684. The page size is 2004. That means I can get 2 rows per page, and the rest of this page is wasted. Now, it's wasted more than just space. I'm wasting I/O because when I read this page, I have to read that wasted space into memory, into the buffers. And that is a huge performance hit. So it's not just the space, it's the memory that it uses when you read this into memory. And look at how much is being wasted in total. Let me get that's what, about 12 terabytes of wasted space, 12 gigs of wasted space on this whole table, 8 gigs of wasted space on this table. So this gives you information about tables. You probably want to go look at reorganizing. And there are a couple of things you can do. One is you can reduce the size of some of the columns to make more rows fit on a page. That is going to get you the best bang for the buck. Second thing you can do is look at different row sizes, page sizes, to see if you had a different page size, would more rows fit on that. So if you went from 2K to a 4K or an 8K or a 16K, could you get more rows on a page and not have so much wasted space? Now, free rows. This tells me rows that this really should be called table info not free rows, because this is going to tell me which tables are about to run out of free rows. And what I'm looking for is, let me just run it, I'll show you. So this table has no free rows, which means the next time you insert a row into this table, it's going to have to do a new extent. It's going to have to allocate more space for this table. It's already got 23 extents, and the next time you insert a row, it's going to get 24 extents. So that means this table is going to become fragmented on disk. Here's another one with no free row, no free space. Now here's a table that has space for 126 free rows before it has to allocate a new extent. Now, extent planning. This is one I've really changed quite a bit lately. I had an old script that I used to use that I don't think was very good anymore. And so I've created this new one called Table Extent Plan. And what it does is it calculates a proposed extent size for your tables. If you were going to rebuild your tables, something like this will help you by calculating a proposed size and a proposed next size. Now, you need to look at these numbers. I use 1.2, so I'll take the size of the table times 1.2, and that will be the proposed extent size. And then I'll say 20% of the table should be the proposed next extent size. You may decide that it should only be, well, the initial extent should only be half of that, or the next extent size should be way more than that. Whatever you do, but this will help you plan. And all you have to do is change these two numbers to see what it has to do. And what I'm doing is taking the number of data pages used by that table, multiplying it by the page size, and then dividing it by 1024 to get the next size in KB. So here's an example. The BSM SQL order line table. It has 50 extents. The current extent size is 16. I'm proposing that it be 2,467,000. I would probably round that up to a little bit more than that, and then a proposed next size. Again, you can change the numbers and you'll get different sizes. Change the numbers to match what you need for this. And the old script I had hard-coded in your page size. This actually looks it up, so it's a bit more flexible than the old script. Now, something I've talked about a lot on other things is index usage, and how do you monitor indexes. And there's an on-check command that tells you the last time an index is used, but what I wanted to know was how efficient is that index. The more reads to writes, the more efficient an index is. An index that is read one time and written one time is pretty much useless. It has to be read one time to do an insert. So that just tells you it was created and some rows updated on it. A index that has 1,000 reads to one write is a very efficient index. And so we're going to use data from 3 sources. Now this is different from the other Sysmaster scripts in that you have to join to a database to get all the tables that are in that database. Because if a table is not in memory, the Sysmaster database is not going to know about it. And I want to go through all the tables in the database. So here's a script, and let's take a look. And I'm going to do a choose and come here to index usage. Now, if I run it right now, my current database is a Sysmaster database. So that's not going to give me very helpful information. I'm going to go select another database. And let me select Benchmark 2. And I'm going to run it. So this tells me in Benchmark 2, there's an index there, and with the space, I can tell that that is a system-generated index. It had a lot of reads, no writes. That's a really good index. In the customer table, I have the same thing. Another index that has a lot of reads, no writes. So that's a good index. In the product table, I have another index, a system-generated index, 33 reads, no writes. That's a great index. In the bills table, this is where it gets a bit complicated. I have an index that has 3 reads for every write. That's the ratio, 3 to 1. That's not so great. However, and this is where you have to use your judgment carefully, it's a system index with a space there. So I probably don't want to delete that index. It's probably a constraint. And this is just an example. You need to know your data when you look at this. Now here in the bills table, I have another index, IDX bills customer number. And again, it's about 4 reads to 1 write. I wouldn't say that is that great, except I know this index well. This index will take this query on this table from 40 hours to minutes. So this is a real important index, even though it's read and written all the time. If it wasn't for that, everything will run a lot slower. So the point I'm trying to make here is you need to look at your data to understand how it works. Let's take a look at another database. And I'm going to select the benchmark 3, exit, go to query, run that. Now I've got some indexes here, and these are great. This is more often what you see is I've got a write, and I've got a huge, this is a really good index. 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 So far, all of these indexes are really good. Now I get down to 9 reads to 1 write. That's not bad. 23 reads to 1 write. Here are a couple of, you can sort of look at the ratio and decide which ones are good and which ones are bad. Now, because you have to do this by, and here's just some examples. Here's a poor index, 1.3 reads to writes, a great index, and a good index. Now, because you have to connect to each database separately, I've created a script called db loop run that will read from the Sysmaster database, create a list of all the databases, and then run a script based on that list. So it's going to go through the list of databases on your system and run whatever script you pass it. So let's exit out of this and let's try it. I'll show you how it works. And so I spell it all right. I'm just going to copy and paste it from the last time I did it. So I'm running the loop with that index script. And it just ran against each database I have on this system. And you can see it closed the database, and then it gives me the results for the next one. And it closed one database, it gave me the results for the next one. And I'll use this loop later on, but it's a really good way of going through all your databases when you want to run one script against all the databases. Now, AUS. Now, I have a couple of things on monitoring update stats and AUS. I think update stats next to backups is probably one of the most important things a DBA has to do. If your stats are wrong, your queries are going to be quite a bit slower and they will be wrong. And making sure your stats are up to date. Informix has AUS, which is the automated update stats, that runs usually every Saturday and Sunday night. You can configure it, but the first script will tell you when it last ran. And so let's take a look at that. Come back here into DB Access. Pick the Sysmaster database and AUS last run. And so this tells me, okay, this is when the automated AUS last run. Now, did this get all the tables? I don't know. This only tells me what tables it got. Is it missing tables? I don't know. We're going to take a look at that next. But this does tell me that low and high were last done on the 31st, and that's because I triggered it to run that night. And that's a key. The second one I have is to go look at this in each database and make sure all the tables had update stats run. And to do that, you have to look at the system tables in each database and certain tables from the Sysmaster database. So let's take a look at that. So this is the AUS last run. This is the update stats by database. And again, I'm going to come look at update stats, but I'm in the Sysmaster database. It's not going to help me. So I'm going to go select, let's select the benchmark 1 database, go into query language, run it, and look at this. The benchmark table has no stats. They've never been run on that. This is how you find out what tables have never had stats run. So here, the state table, it tells me when low was last run, tells me when high was last run, and also tells me how long it took to run high. The zip table tells me when low was last run, when high was last run on that table. And I can see it. Zip is here twice, one on the column city, one on the column state. So that tells me what has been run in that database. Let's go pick another database. Let's pick 3, benchmark 3. Again, this is telling me, okay, on the customer, I had low done, I had medium done. I had, on the column C first name, I had medium done. And it tells me when and how long it took to run that. And again, you saw as I was going through this, let me restart. The history table has had no stats done. That's what you're looking for, is tables that have no stats. So this tells you the table and the columns that have update stats run on them. And if a table shows up here empty, well, this one has had low done, but it's had nothing else done. So the optimizer is going to think there are no rows in this probably. So that's update stats. Now, before I dive into this last one, this is another one where I like to do, let me get my script here. I run it through that DB loop. And this will go do it for all the databases. So now I can take a look and see for all the databases on my system. I've got benchmark 1, 2, 3, and 4, and you know, when update stats was done. It's a really good way to loop through and see that stats were done. Now, The last one I want to talk about is what's the most expensive SQL currently running. And there are a couple of big caveats on this. This has caused assert failures in some versions. So please test this. Do not run it in production. Test it on development before you try it. But what it does do is it looks at what's running right now. And there is a table I'll show you in a minute where it has all the current queries and what the optimizer estimated their cost is. And to me, I find it most helpful to save this data, run it like once an hour, save it, look at the results, and then pick the top 10 most expensive queries. When I used to do performance tuning projects with clients, I would run this, get 10 queries out of that, and say, let's go figure out how to make these run faster. And that gives you something to focus on instead of saying, okay, what do you think we should do? This tells you what the optimizer thinks is the most costly queries. Now, sometimes it could be as simple as doing update stats on the tables involved. It's almost funny when that's the solution. You don't have to change the SQL. Sometimes it can be updating the SQL. Now, SQL trace. This is not SQL trace. I just want to say that I do have separate presentations on SQL trace. They capture data. This doesn't capture data. This just shows you what's running. As soon as something's finished running, the data isn't there in memory anymore. So it's based on a table called SysSQExplain. That's a documented view, and that is based on an internal table called SysBlock and SysConBlock. And so in the couple of versions where there has been an assert failure on it, it's because of a problem with these two internal tables. And support has been very good, saying just don't run it on these versions. Now, this is the field we're looking for. In the view, it's called SQX estimated cost. That tells you what the optimizer thinks the cost of that query is. Small numbers means the optimizer thinks it's going to be fast. Now, it could be a small number because the stats are wrong. This doesn't tell you how long anything took. It doesn't save how much information it actually took. It just tells you what the cost is. But I found it as a great way to look at it. And here's the underlying table. The SQL statement is right there. So you get to see the SQL statement. And what I've liked about this is when I do it with developers, you can usually bring up the top 10 most costly SQL, and they're like, oh, I wrote that. I know what it is. So it's very handy. What I do is I create a table. If it doesn't exist, if it exists, it just inserts into that table. So it will keep using it. And then I insert into it, and you want to run the script like every hour or at some regular set interval. Just as an example, let me go back here and go into DB Access and go back to the Sysmaster Database and SQL Cost Explain. Table already exists. So boom, it tells me, okay, here are the SQL statements that have cost the most. This first one, because I've run this several times in the last few days, this first one has the highest cost. It's been executed 1,100 times. The second one has the next highest cost. It's been executed 1,100 times. I usually try and look at these that have now something like this. There's nothing really to optimize here. That's a simple insert. Maybe it's got a lot of indexes. That may be why I suspect that's why that costs so much. Here's an update statement that has only run 3 times, but look at the cost of it. That tells me, and you can actually see this. This is the SQL I just ran, and it's run 17 times. Here's another select statement that's run 1,900 times. A select statement that's run 1,100 times. I can actually exit out of here and run it one more time. This will, over time, and I think the best way to do it is run it once an hour. Maybe, and then at the end of that, unload all that data and take a look at it. What I'm doing at the end, let me bring the script up. So after the insert, I'm just doing a select trim on the SQL statement, summing the cost and doing a count of the executions and grouping it by that SQL statement. So if the same SQL statement is done 100 times, I'll see it once with a count of 100 here. But anyway, this I've found very helpful to try and figure out what the most expensive SQL is on the server. So questions, please ask them in the chat, and I'll be around for a little bit. As I said earlier, I'm retired. You can send me an email with questions. I may be off on an adventure someplace. I've got some great trips. I'm going to Indonesia next month, and I've got all kinds of trips planned for this year, so I may not respond right away, but I love hearing from folks. So thank you, and on behalf of the IIUG, I want to thank you for listening in to our Tech Talks. Please go to our YouTube channel to subscribe to them. This one will be on the channel a few days after I've finished the talk, and it's been a privilege working with the team the last 2 years on the Tech Talks. I feel very confident that I'm leaving it in good hands with Bruce and John and Rhonda, who are going to continue these this year, and I know they've got some exciting ones planned coming up. And with that, I will stop, say goodbye, and have a good day. Thank you very much for attending the Tech Talk.